the point of this class is to get you guys comfortable working with data. And a piece of that has to be your ability to recognize when the data is good or the data is bad. Similarly, when the presentation of the data is good or the presentation of the data is bad. So I'm going to show you two data visualizations. They were both published in one was published in the New York Times. Which regardless of whether or not you like the Times as a periodical, you could argue they have a lot of resources behind their data visualization department, and they have an actual data visualization department. And presumably, because the Times is very well respected, you would assume that the people employed in that space are very well trained and regarded. The other one was published by the National Institutes of Health. So both of these data visualizations were published by groups and organizations that have the resources to kind of put these things together. And I just kind of want to get your thoughts on them. So let me here we go. All right, let me share my screen. Okay. So here is this first one. And this is after the Booker Prize, which is a literary prize, an annual literary prize for fiction. The New York Times published this infographic that sought to explain what makes a prize-winning novel. So the list on the far left side, those are novels that were nominated for the Booker Prize that year. What do we think about this visual? Initial thoughts.
It's horrible. It looks like garbage.
It's, yeah, it's horrible. Liliana, apps, right?
Super confusing.
Super confusing, right? The color coding is, I guess, in theory, supposed to help you trace. It's nearly impossible, right? The only thing that I can take away from this is that whatever black is, which is hard to see, is seemingly larger than anything else, right? This is an example of a data visualization that is far too complicated, right? There are ways that you could have simply listed these things that are represented by this wheel on the side and just put the total number of titles to which that category pertains, right? A pie chart might have done better. This is definitely an example of trying to do way too much and be way too creative with data visualization. Okay. Next one, I'd like your thoughts on. So this is how baby boomers describe themselves. So this is how the population of people, some of whom may have been your parents like me, but if you're younger than me, they probably weren't your parents, who were born right after World War II. And this is a description of how baby boomers describe themselves. Leaders, willing to learn, tech savvy, people savvy, or creative. What are our thoughts on this one?
The percentages don't add up to 100.
The percentages don't add up to 100, which, given that there is a complete figure here, doesn't exactly make sense. Yeah. Other thoughts?
Looks like a bathroom sign instead of
It does look like a bathroom sign. Yes, it does look like the universal people symbols around restrooms, for sure. Liliana.
I'm not sure if I understand the why is everything kind of broken down like this? Why is it creative or at the feet? What's the point of the chart?
Right. Right. Does leadership come from your head and creativity comes from your feet? Right. There's something using the specific image of a human, right? And specific parts of the body lend themselves to some additional conclusions or questions. Whereas some sort of stacked bar chart could have worked for this. Could a pie chart have worked for this?
Well, not necessarily, because it doesn't add up to 100.
Right. So if pie charts only work if the total is 100%, if you need to present data where the total amounts to more than 100% because you can have overlapping categories. You can use stacked bar charts and similar types of bar charts and histograms to do that. Yeah. But certainly using the human and putting these pieces in the various places they are. The one thing that I thought of this, which maybe also speaks to how old I am, is I thought maybe the tech savvy piece was there because baby boomers wear cell phone clips on their belts.
I'm sorry.
It's fine, right? Which I think my father-in-law still does to this day. And he is in
What
his mid 70s. Yeah, go ahead.
what's throwing me off also and is the 78%, even though it's like two legs, looks
Yeah.
vastly smaller than the
Yeah,
61% to
the
me.
proportions are so first of all, besides the fact that it's quite confusing, besides the fact that the percentages don't add up, right? Given that it's in an entire there's a complete shape, the proportionality of the shading also doesn't make any sense,
Right.
right? And certainly you could argue like willing to learn maybe should be the brain. Right.
Mm.
So I think there's a lot of things, again, wrong with these. These are just kind of two examples of bad data visualization. And as you guys keep going and digesting more information, reading more quant work, or even just like engaging in popular media, news, whatever you get your information on anything, I do urge you to always be a bit skeptical and potentially critical when you feel like a data visualization is trying to do too much, right? Sometimes the absolute simplest portrayals of things are the best, right? If you're trying to show too many things, it defeats the purpose of using a visual, right? Visuals tend to be used because people think of them as more accessible rather than showing people tables crowded with numbers, right? But if the visual isn't actually doing a great job, then what's the point in it? So I will also point out after this on Brightspace, under assignments, there is an extra credit opportunity if you guys would like to kind of do a little bit of sleuthing and try to find your own examples of good versus bad data. So all you have to do for the assignment, which is under assignments on Brightspace, is provide an example of good and an example of bad. So you can present the data via a screenshot, table, bullet points, or write it up with reference to the source if you found it online. And for each example, tell me why you think they are good or bad in one or more sentences, right? So there are a number of social media accounts that are data oriented and kind of prevent data. There's Charter, CHARTR is one of them. Also, like the National Institutes of Health, the National Institutes of Mental Health, the Center for Disease Control, they all have Twitter accounts and they will often put up like data visualizations or like a statistic of the day. So you can pull from that as well. If you find something in an article that you think is particularly good or bad, please feel free to include that. It's entirely up to you. So that is now open under the assignments. So from there, um, oh, Al, this is a good one. Let me share my screen. Al, are you there? Yeah. Let me share the screen and then you tell us why you put this in the chat. Let me see if I can make this big. Yeah, there we go. So let me go back to Zoom and share my screen. And where did you guys go? Oh, hold on. Back to meeting. For some reason, this is being. Okay, so share. Here we go. Does everybody see this? So, Al, why did you put this in the chat? Crypto bets and real estate deals. Inside Trump's $2 billion year.
Right now you're currently presenting a PDF on scattered plots.
Oh, sorry.
No, it's good. I like scatter plots.
Scatter plots are fun, but not as fun as data visualization. Share. Desktop. Now let's see if I can get this to work now. There's that. Hold on, guys. Sometimes I'm good with the tech, and sometimes I am not good with the tech. I know what to do. Okay. Get out of this. Give me 1 sec. All right, and then let me go to Al's example. Hey, Melissa.
Hi, thanks.
All right. We are good now. Make this bigger so everybody can see it. And then view. Okay. Here we go. All right, now can we see it?
Yeah.
All right, so crypto bets and real estate deals inside Trump's $2 billion year.
Yep.
What do we think about this data visualization?
Come on, guys. Show me the money.
Well, literally.
Show me the money. Everybody's silent here. I guess they don't like visuals. Nobody has anything to say?
What do we think? First of all, is this conveying let's start simple, right? The purpose of this is to show where Trump's business income came from in 2025. Is this doing that?
I'm not entirely sure what it's doing.
The math is not mathing.
The math is not mathing, okay? So we think it's not.
Well, it adds up to more than $2 billion.
It certainly adds up to more than $2 billion, right? The 2.2 billion is not what you get when you add 1.4 and 575 million, right? Because that gets you to 1.975. When you add the remaining at the bottom, settlements, royalties, licensing fees, and others, it still doesn't get you to that. But my other question is, it's not entirely clear that settlements would be included in business income. Others also pretty broad, right? There's also this throwaway comment at the bottom here. The president's investment accounts also made more than 20,000 trades last year. Okay, is that where the crypto, were they all crypto? Were they, right? I think it's confusing. It's clearly a lot of money, but it doesn't necessarily match the headline, right?
I don't understand the formatting. Like this block, I don't, I'm sorry.
What is
I don't
this?
even have the words.
What is the source of this? What paper put this in there? Where is this coming from?
This is the cover of the Wall Street Journal for tomorrow's paper.
Wow.
That's live on the Wall Street Journal website right now.
Yeah.
Wow.
So the crypto real estate part, at least in terms of the like shading, kind of makes sense. 75%, 25%. The stuff at the bottom doesn't make sense. You're seemingly measuring things across two kind of axes, and it doesn't seem to add up. Now, is this accompanying an article, or is just a standalone infographic, Al?
This is a article that's going to be published tomorrow because the news was released this morning.
So it's possible that the article it seeks to kind of use the confusion here to help convey a message about the confusing nature of the income the president is receiving and and maybe, but I can't say that for sure. I would say generally as an infographic though, this is not helpful, right? If you're going to give people total dollar amounts and then break things down, they better add up to those total dollar amounts, right? If you're going to reference trading, what is that in reference to? Is this all these parts of income? Because seemingly, what trades would you be? Real estate seems to imply buying and selling stuff, right? Or the value of their real estate holdings. I'm not sure where trades would come into that, right? So I think this definitely needs a lot more information and explanation, right? It looks real clean and simple though. And I imagine a lot of people will look at it and think, oh, okay, this is good. I also imagine a lot of people, because of where it is being published, will look at it and not necessarily understand it and think what?
Well, when I first saw it, the way it because it's a heat map. It's supposed to represent a heat map. And unfortunately, they did a really bad job at it because it doesn't add up to, like we just said, 100%. I would have done more of a bar chart whereby I would put the lowest, the 7 million at the bottom and the 1.4 billion on the right. And then you could see the progression. And then you could put a total amount, including everything, that adds up to $2.2 billion
Right.
as an aggregate.
But given where it's being published,
Oh yeah, it's a primary source for financial data, and
right. And most people are going to look at this and probably have the exact same react, even if they don't know what a heat map is. They're going to have similar. It says 2.2 billion, but 1 point, what is it? 1.4 and 575 don't get you there. What are they probably going to conclude though? The Wall Street Journal's wrong?
absolutely not.
No, what are they going to conclude?
Well, this is a biased paper because they want to sell paper or digital
They
subscription.
might conclude that, but in most cases,
They're going to conclude that I must be adding something wrong.
they're gonna conclude I'm wrong.
I must be wrong. Like my math must be off because
The
this
Wall
is
Street Journal,
yeah.
which next to the Financial Times, right, are considered the foremost financial publication in the world, put
Exactly.
this on the front page. That must be right. I must be wrong, right? And this is also the way data visualization can be used to like subtly manipulate things. And that's why it's like critically important, right? That you find good sources of information around this kind of stuff, right? That's why the construction of survey items is critically important so that you can be certain that the manner in which you are interpreting the data is valid based on the manner in which the data is collected, right? So Liliana, if I may, in her survey that she submitted, she has currently a statement that asks about the respondent to assess on a Likert scale, strongly disagree to strongly agree. And correct me if I got these wrong. The question asks about the extent to which something is in support of and knowledgeable about. Did I get it right?
I think so, yeah.
In the same question. Well, what if you think someone is knowledgeable about something but doesn't support it? How do you answer that? She needs to separate those out into two statements. One statement assessing the extent to which you agree that the people are in support of, and another statement that asks the respondent to whether they agree that the person is knowledgeable about, right? This is why these kind of tiny, tiny nuances are so important, because bad data instruments collect bad data, which then leads to bad conclusions, and then which in turn can lead to bad visualizations. Now, in this case, there's probably some rationale behind why they're doing this. It's probably about the simplicity of it. I also think it's good clickbait, right? It's catchy right now. And having not read the article, I can't actually speak to it, but I would say that the value of good data and good data visualization really should also be that it is universally applicable, assuming like a standard level of reading comprehension, right? Like I'm not saying all data visualization needs to work with 6-year-olds, but it should be clear enough that anybody with knowledge of that, whatever language it's written in, can look at it and at least have a takeaway, even if they don't know anything about the subject itself, even if they don't know what crypto is, right? They should be able to look at this and be like, oh, okay, right? Now, the larger context here, which is not available in the visual, but if you click on the article, I guarantee somewhere in that first or second paragraph is reference to the fact that most presidents are not actively earning income while they are in office, right? Because their money goes into trusts. Trump is the first president in the modern era who is actively buying, selling, and profiting off of things, right? So that's also kind of not evident in this visual too. So perhaps if you weren't familiar with like our American government system, you might not see something wrong with this. Any questions or thoughts on data visualization? Okay, I would also argue if 2.138 billion is the exact amount, rounding it to 2.2 is statistically incorrect, but we can talk about that later. Okay, so let's return back to designing a quant study. What we're going to do tonight is we're going to start by going over some specific quantitative methodological frameworks. We're going to talk through meta-analysis. We're going to talk through experiments and longitudinal design. We're going to look at a couple real-world examples again. We'll do a quick review on variables, and then we're going to dive into SPSS, go back through descriptive statistics. We're going to talk a little bit tonight, in addition, about the idea of distribution, which is really important when talking about quantitative analysis, because distribution really determines what types, of statistics that you can compute. And seeing how our bandwidth is, we may end tonight by talking through associations, which can be assessed via correlational analysis. So let's go back to some slides. Okay, so if you recall, quant studies are all about using variables to test theories, right? So you either use existing data somebody else collected, or you collect your own data via an instrument that is easily translatable to variables. And these are the things that you will analyze, right? So variables are characteristics or attributes of your unit of analysis. Your unit of analysis could be individual people, it could be organizations, it could be groups, it could be colleges and universities, it could be kind of groups of colleges. It could be like the Cal State system versus the New York State system. It can be countries, states, etc., all the way up to the most macro level, all the way down to the most micro level. Variables need variation. This is critically important. There is no value in analyzing a variable if there's no variation in that. If 100% of your sample responded with the exact same answer to a question, there's no variation in that variable. For quant, when we talk about variables, when you are planning and designing your study on the front end and thinking through your concept maps, we often use the word construct, right? So your constructs come out of your conceptualization of the problem and your conceptualization of your study. And your construct should be able to contribute to survey or other instrument items that collect information. Oftentimes in quant studies, there is a temporal order to things that you hypothesize. Something causes something to be, or you think something makes something better or worse or larger or smaller. We talked a bit a couple weeks ago about types of variables. briefly to just remind everybody, the most important thing is to understand the difference between your independent and your dependent, right? Your independent variables are your causes, your influences, things that you think affect an outcome. Your dependent variable are your outcomes, the effects, the results. They are dependent on the presence or absence of the independent variable. They are dependent on the size or scope of the independent variable, right? If you are looking at income as a dependent variable, education is often an independent variable. If you are looking at income, age is also often an independent variable, right? Then there are three other types of variables that we will talk about and that come up in analysis, right? So there's mediating, moderating, and control. Your control variables are your demographic variables. All statistical models that are looking at data collected from human beings should include control variables. They should include things related to the characteristics that are individual and personal to your units of analysis: age, race, ethnicity, sex, things like that. Control variables can sometimes be your most important independent variables, right? If you are simply trying to understand whether there's a racial or ethnic gap with respect to something, race, ethnicity are your independent variables. Okay. If your question is about four-year college graduation rates of first generation Americans versus others, right? Then that status is not a control variable. It's actually the independent measure you think may cause the outcomes to differ. But if you are looking at participation in a program like a C-STEP or an opportunity program, right, and its impact on a graduation rate, you should also control for the characteristics of the students that may be in those programs, right? So a lot of this depends on what your actual research questions are and the things that you are hypothesizing to have an impact. Okay, the other two types of variables are mediating, and these are intervening variables that stand between the independent and the dependent, right? So one of the simplest examples of this is the type of exercise, right? So if you're trying to look at hours exercise and its impact on weight loss, a mediating measure of actually what that exercise is can really help explain it, because you could go for a leisurely walk where you don't break a sweat for 2 hours, or you could run on the treadmill for 30 minutes at 10.0, right? That will have a difference on the relationship between the amount of time exercised and weight loss. And then there are moderating. These are interaction terms. These are when you take two variables and you put them together, right? So these are independent variables that you think might affect the direction, strength, or scope between independent and dependent variables. So if a person has some sort of previous health condition that may impact weight loss, that could be a moderating variable if you interacted that with the type of exercise they were doing. In this class, in terms of what we will run, in terms of statistical tests, we will not deal with moderating. That's advanced quant. But we will talk about independent and dependent variables. We will talk about mediating variables and control variables. And then the last type of variable is actually the unmeasurable, right? These are the things that you talk about in the limitations of your study. When you talk about the limitations in chapter 3 of the methodology, when you talk about the limitations of your findings in chapter 5. These are things you couldn't measure, that you didn't see, that may be at play here, right? Maybe there was some sort of kind of serious incident that happened on a college campus that really impacted the students who were enrolled in like 3 consecutive semesters, which affected something in terms of graduation rates, but your survey and study didn't ask about that, right? So something may be at play here that you're not privy to. There's always gonna be confounding external things, also in qual, right? A person's responses in your interview with them could, which is why it's important to have lots of follow-up questions and prompts and lengthy interviews. It could have been influenced by the fact that maybe they got in a car accident on the way home to get on the Zoom with you. And so they're feeling maybe physical pain, but also stress, right? There's always going to be factors that are kind of limitations and unseen in all of this. Any questions on types of variables? Okay, so let's talk about quant study designs. So survey design, which we talked about last time when we talked about good versus bad surveys, is certainly the most common. Any sort of intake instrument, whether it's a formal survey that you give to the respondent and they answer questions related to opinions, behaviors, facts, or any sort of, you could think of if you were using the National Clearinghouse data set that has all the data on like incoming college freshmen and then graduation rates, right? You can think of that as survey data as well, right? Some sort of database that has repeated measures across large numbers of units, right? In that manner can be thought of as survey methodology. The other most common quant study designs are meta-analysis, which a couple of you ended up reading for your quant articles, and experimental. Very, very different in nature. Meta-analysis, similar to using public use data. And this is a little pitch if anybody's on the fence about quant and maybe thinking about their timeline. If you do meta-analysis or you do a quant study where you use existing data, you don't go through the full IRB process and are not subject to the same deadlines. You still have to do the full application, but you do not have to wait until they meet because it's an expedited review because you're actually not dealing with human subjects yourself. So,
Could you repeat that?
yeah. So for qual and quant studies, where you are getting information from people or getting data that you have to apply to get, right? Like you want the data from the school district, you have to get the school district's approval. Like not what's on the Department of Ed website, but like whether or not teachers were disciplined for whatever. You have to go through, you have to do the full IRB application. You have to submit it by the deadline, which is usually towards the end of every month, the last week of every month, with the exception of June. They don't have a July meeting. And then they meet, the IRB committee comprised of faculty, all read the applications and then meet to discuss whether you are approved, whether there are some things you need to fix, or whether you need to come before them to talk through and justify the study. So there is a bit of a wrinkle in terms of your like ability to seamlessly go through because you don't get to decide when you defend your proposal. Your chair does. Your chair says like, Verna, now you're ready. But Verna, now you're ready may be the day that the application is due. And you have to have defended your proposal and then make any edits in the proposal and the IRB application based on the Q&A in your dissertation proposal defenses, right? If you are doing research that does not involve human subjects, so either you're doing a meta-analysis where basically your sample is comprised of a large number of studies, or you are using, for example, the State of New York's Department of Education public enrollment data set that has the number of students in each public school district in New York State and a whole bunch of information on them that you can just go on nydoe.gov and download. You don't have to go through that full review. So you can submit your application whenever, and they will basically like read them on a rolling basis. Because the kinds of things that require inquiry and scrutiny and potentially discussion and debate, like the language you use to request the data or the language you use to get consent and whether or not it's coercive, doesn't apply because you're not actually dealing with humans. Does that make sense? Okay, this is a new thing. They used to require you until 3 or 4 weeks ago, and then a bunch of us petitioned them and were like, this is ridiculous because I have a number of students doing meta-analysis where their sample is literally comprised of hundreds of articles. There's no people involved in this. There were people involved potentially in the original studies, but my students are not going to interact with them at all. They're going to interact with PDFs, right? So it is something to consider that not only does secondary data, which meta-analysis would be included in, help with data collection and getting a large enough sample size, but it also kind of quickens the path to IRB approval. And you can't start your study without IRB approval. Any questions on that or even IRB generally speaking? Yeah, Al.
So if we're gathering data from multiple institutions, which is publicly and readily available, um, since since we're not dealing with people,
That would be expedited. If it's publicly available, you go to the institution's website, you download it. Yes. Now,
yeah.
there are restricted use data sets that you have to apply for. So like if anybody wants to study, there's no publicly available charter school data set. There's a couple of, like, sometimes the states have the enrollment numbers, but charter schools and charter school networks are very protective of their data. You can't get that. You have to then request it, and that's full review. But if you are going across, if you are studying, and forgive me because I'm blanking on who's doing this. DEI, who wrote the memo on the DEI and the job application? Rhonda. If you, for example, were studying the articulation of DEI policy in the post-Trump space in higher ed, right? You're going to college and university websites. You're finding their DEI departments if they still exist, and and maybe they've been masked as something else, right? Like Manhattanville rebranded it, and I wish I could remember what it is because it's the most absurd branding. It's like the Center for Excellence instead of DEI now. Is there a code of conduct? Is there a mission statement, right? That's all publicly available. Rhonda goes to all of these websites, copies and pastes, has a coding scheme perhaps, right? Starts building. If you're doing quant, maybe you're like quantifying this. If you're doing qual, you're doing like detailed coding of the language, right? If the DEI office isn't there anymore, have they like snuck it into other spaces? Is it under like the Center for Accommodation? That's expedited review. Anything you don't have to ask permission for, it doesn't involve you directly going to humans, is expedited. Other questions?
If it's behind a paywall or restricted access, then you got to ask permission.
If it's behind a paywall, well, anything you have to fill out an application for, that would actually probably be based on what the organization that you're getting the data from requires. So if an organization you're getting the data from has a paywall, there's usually a lot of rules around not like how you analyze the data, but how you keep the data. So you probably need like a data protection plan in place. You might need like a air gapped computer that's not connected to the internet so that and like all the files to be password protected. And that would need to go through IRB, but they would also call that exempt as well. IRB would read that on a rolling basis. But you would need like a data protection plan basically in that case. Rhonda.
Okay, so if I'm looking for money that was dispersed to all the land grant institutions. All right, so you have the HBCUs,
Yeah.
you have the others. Is that
That should be all that by law. That should be public use. That's public dollars.
okay? So then I wouldn't have
And those institutions, let me I don't know the one kind of thing I don't exactly know because I'm not familiar with the HBCU governing structure.
Hmm.
Um, if they are, if all land grant HBCUs are, because most land grant predominantly white institutions are public, right? There's a couple that were initially land grant, but they switched like centuries ago. I
Hmm.
don't know what the balance in the HBCU is. However, if there is funding that was distributed to them solely because of that distinction and designation, then that's public dollars. So there should be in the public domain somewhere record of
Okay.
that.
Well, there
Whether
should be a,
that is sorry, whether that's map included with all the other financial stuff would be trickier.
mm,
Whereas like a Michigan State, right, and an Ohio State, those financials are publicly available and would have the distinction of like what money is coming just because they're that and what money is coming from other stuff.
and so
Um,
for those institutions, it's supposed to be federal money, and they all had state matches, didn't they? So
in
all of that.
theory, yeah.
Okay.
So there are I know that there are less than 10 private land grant institutions. I don't know if that's inclusive of the HBCUs because like Cornell is a land grant institution. I don't know if that's inclusive of the HBCUs. If it is, however, and you could easily Google this, right?
Hmm.
Then that's a manageable number to figure out in your sample.
Okay.
Um, and there are public HBCUs too that, right? So
Hmm.
I think that I want to say Tuskegee
Tuskegee's private.
was a land grant though.
Oh yeah. Hmm.
Okay, yeah. So then maybe that 10 must it probably is inclusive of that. But yeah. Um any public funding like that should be available in the public domain.
Okay.
Now, these are the kinds of things where sometimes if shady stuff is going on, all of a sudden that year's missing and
Yeah.
but that in itself is a data point
Yeah.
and worthy of kind of digging. Other questions on IRB or things like that? Okay. So meta-analysis is essentially a quantitative methodological design where you combine the results from a set of studies that addressed related hypotheses or topics, right? So this is a useful methodological framework for a topic and a phenomenon that has been studied. If you are looking at something and there's no literature on it, a meta-analysis is not possible, right? Um, it's 2026 now. In 2021, I had a student try to do a meta-analysis of COVID. There wasn't enough yet. Right. They wanted to do a study of parent and caregiver reactions to homeschooling. There simply was not enough. Right. So temporality can sometimes matter here, but for the most part, and in theory, you need two or more existing studies, but if you want to do any sort of serious quantitative analysis, you're going to need a lot more of that, right? And the idea here is that across different studies that may have used different methodologies, right? Interviews, surveys, right? There is a common hypothesis or a common research question and a common finding that can be compared to each other, right? Meta-analysis allows you to distinguish trends. It can allow you to determine if, in fact, there is a common truth across all these studies. It can also help you figure out if previous research perhaps wasn't of the quality that it should have been, right? Sometimes there's a lot of flawed research in a given space, and somebody's basically trying to come up with a better way to study something. So a meta-analysis could be part of your methodological plan wherein you try to identify kind of what exists there and what might be problematic. It's a methodology that can be used to resolve uncertainty. If you have like two competing findings, you could then say, well, I'm going to go back to 100 studies and see kind of overall what the general patterns and trends are here. The benefit of this is that it is fairly easy to get your data. It can be time consuming though, because you need to read all your articles. And it can allow you to generalize across a bunch of different populations, right? You can easily do hypothesis testing here. Now, there are certainly some biases here, right? Because if you're doing a meta-analysis in a doctoral program, the odds are that you are proposing to sample from peer-reviewed publications, and there definitely is a bias in what gets published and who gets published, right? Even though a lot of peer review is blind, there are certain kind of tendencies and preferences for how certain information is presented. Also, like who's in the academy, who are research faculty, what do they look like, what are their backgrounds? So there are some biases here. The general idea behind the meta-analysis is simply this, right? So you have multiple studies that you compare to determine an overall effect size, right? So you have study 1, study 2, study 3, study 4. You analyze and appraise the studies, you do a systematic review of them, and you come up with a common conclusion. It involves a pretty complex filtering system, right? So you would go to some sort of database, EBSCO, ERIC, Google Scholar, JSTOR. You put in your keywords, right? You pull up the total number of sources. Then you got to remove duplicates. You got to screen for relevance. You got to make sure you have access to things, full text, right? If you are trying to only look at quant stuff, you got to pull out all the qual. So there's a complex sampling process to meta-analysis, even though you're not actually going to people. The IRB, though, is not at all concerned with the kind of mechanisms and plan you follow to get this because there's no issues relating to coercion and subjectivity. Here is an example from a student of mine. So they did a keyword search and they identified 1,570 publications, right? Then they did basically like a hand search where they were in the library, like perusing through tables of contents of things. From the 1,570 in the keyword, 22 publications were initially not included, right? And then you basically get it down to 8 excluded, 14 coded, right? This is basically your sampling plan. You start with the absolute largest size through your initial search, and then you, through screening processes, whittle it down. I had a student recently graduate who did a study of gamified learning via meta-analysis, and he was interested in comparing tabletop games, role-playing games, and traditional board games and their impact on achievement. And basically, he had 3 of these sampling diagrams for each of those 3 types of gamified learning. And he started with Google Scholar and he put in academic achievement, K-12, tabletop games, and he ended up with, thousands of articles. And then he worked with Paula Moskowitz in the library to help filter that down. So he basically ended up with a final sample that was 30 some odd studies on the tabletop, 30 some odd on the role playing, and 30 some on the board games. And he compared them to each other. The one unique thing about meta-analysis is there is analysis that has to happen in chapter 3 because you have to pilot your sampling plan because you have to prove to the committee and yourself that you can actually go out and get enough information on this topic, right? So you kind of go through a mini sampling and filtering process and a mini analysis that goes a step beyond kind of the normal piloting or field testing. Any questions on, meta-analysis? Okay. Next, experiments. I imagine experiments are probably familiar to you from kind of science class back in the day, right? The idea where you are comparing two or more groups that are similar except for one factor, right? There's one kind of level of intervention or manipulation or reform or progress that is happening, and you want to see if that is effective, if that is positive, if that is negative versus another, right? Um, Experiments can occur in labs, which are highly controlled settings, but they can also occur out in the field, right? A field experiment could be if an institution implements a new hiring process wherein all the applicant screening is done by AI up until the final interview, and you test what the pool of applicants looks like in that new scenario versus the previous one. That's a field experiment. Right? Now, that wasn't intended to be studied via experimental design, but anytime there are two groups that are similar in every aspect, except for one sort of condition, manipulation, or reform, then you can study them in this way. If you, for example, are interested in looking at the effect of a curriculum on something, that's an experimental design. Sometimes it's called field experiments, but sometimes it's also called quasi-experimental. And the reason it's called quasi is because when it's done in the field and you are not actually implementing the thing, you have very little control over like what the conditions under which these things happened, right? And traditional experimental design assumes high levels of control and that the only difference is whatever the experimental condition is, right? So in a true lab experiment, when they're testing the effect of a drug, right, they take two people who share socio-demographic, physiological, physical, mental health conditions, almost identical, right? Same age, same background, and one of them gets a drug and one of them gets the placebo, so that you can actually compare the effect of the drug, right? It wouldn't make sense to compare the effect of a drug on an 86-year-old man versus an 18-year-old man, right? Other kinds of lab experiments usually are able to highly control the conditions under which you get the information. And so that's why when it's out in the field, it has to be quasi-experimental. Now, if you yourself as the researcher are implementing whatever the condition is, then it would just be a field experiment. But if you're using like data from somewhere else, or you're looking at like reading scores before and after a new curriculum, that would be quasi-experimental. There's a lot of good examples of experimental design. There's also some terrible examples of experimental design. Are you guys familiar with the Milgram experiment? So it's commonly used in like intro to psychology classes in undergrad. So it's a study from the 60s out of Yale University where Stanley Milgram, who was faculty member, was seeking to measure obedience to authority. He was trying to understand why ordinary individuals would inflict pain on other individuals when instructed by an authority figure. So what happened was the setup was there were participants who thought that they were helping in a study of memory, and the participants were on one side of one-way glass. So the participants were on one side with glass they could see somebody else at a table and the other side. The idea was the authority figure instructed the participants that the people on the other side of the mirror were being given a memory task. And every time they answered the question wrong, they were to press this button to administer an electric shock. And that the more questions they got wrong, right, the higher the voltage. And the people on the other side who were in on it were actors who were instructed to play up as if they were being shocked, right? So what initially was like, ow, eventually became like screams in agony. Okay. And what Milgram found was that over 60% of the participants went all the way up to the maximum voltage of 450 watts. Even though they heard and saw the people like writhing and screaming in pain, right? So, one, this says a lot about people and obedience to authority, right? And then when asked and debriefed, right, they were like, well, this is what I was told. Now, this is an example of an experimental design. It's also an example of a terribly unethical study. Because even though no humans were physically harmed in this experimental condition, they were greatly mentally harmed. Because what is the social psychological impact of feeling like you are administering electric shock to seemingly normal, innocent, fine people, right?
Sounds like Nuremberg.
Yeah, yeah. Milgram wanted to study this post the Holocaust to understand why SS officers were so comfortable administering the atrocities of the Holocaust, especially given that there was evidence and historical fact to back up that in many cases, some of the SS officers had grown up in villages and towns and communities next to the people who then became prisoners in their camps. Yes, Al.
Yeah, when you were describing this, I was like, it's like Nazi type of stuff.
Yeah,
And
Yeah,
I'm
that's
like,
the first thing that came to my mind
Yes,
too. I was like,
oh,
very
yeah,
much so.
this is
And you would think that we would have stopped this stuff. But one of the other more kind of controversial and commonly used in intro to psych classes came 10 years later, and it's called, have you guys heard of the Zimbardo or the Stanford prison experiment? So this is where a Stanford sociologist wanted to understand the psychological effects of kind of power dynamics and authority and powerlessness. This would never fly today by simulating a prison environment using randomly selected male college students. So he took, this actually happened. He took a group of undergraduate males and randomly split them into two groups, prison guards and prisoners, right? It happened in the basement of one of the buildings on campus. They were paid, I think, like $10 a day. They were divided by a coin flip, basically, into, as I said, prison guards and prisoners. They were given uniforms that reflected each of those roles. The study was supposed to last for 2 weeks. It was shut down after 6 days due to severe emotional breakdowns, as well as like cruelty and sadistic behavior on the part of the guards, right? Guards were instructed to respond and react to certain behaviors with certain ways, with verbal abuse and threats of physical violence. Prisoners were instructed to act in a certain way, which might prompt some of that. It was basically trying to examine the effects of situational variables and the extent to which that could predict people's behaviors, right? You take peers who are in terms of all aspects of their lives equal, right? In most things, right? White, male, college freshmen, and you split them into two groups and you tell one they have power and you tell one that they don't, and what happens, right? This also clearly super sketchy and unethical, right? There have been a couple of other since the 1970s that have tried to look at role conformity. Nothing has really approached that level of kind of questionable ethics as that one, but I certainly think that sometimes when people are trying to measure the effects of things, certain emotions can be primed, right? There are a lot of studies that have tried to use an experimental design to study racial bias. Some of the tactics in that are often questionable. I think the ones that are most commonly assumed to follow kind of institutional review guidelines are ones that use computer automated kind of images and ask people to react to them in real time rather than using real people. But certainly when you're trying to manipulate something, right, the ethical ground can get a little shaky.
What about lobotomy?
Question? Yeah.
Lobotomies?
I would
I
argue
heard
that,
they did them. Plastic
yeah,
surgery.
I mean, that that's all pre-institutional, the existence of institutional review boards and medical review boards, right? Since
No.
colleges and universities and research centers have instituted a common set of practices around ethical practices in research, none of that uh, eugenics, things like that is all gone by the at least gone by the wayside in the like on the up and up in the visible space wherein research is consumed. I can't say things aren't happening, under cover of darkness, but for the most part, that's actually why institutional review boards exist now, right? It's to kind of protect human subjects, right? And remember, what are the three most protected class? If you've done your city training, what are the three most protected groups in human subjects research?
Children.
Children.
Wait, say that again, Verna. Children.
Children.
Who else?
Oh God, is it the elderly and disabled?
It is not the elderly or the disabled, which
Damn,
begs some
really?
questions.
I knew, well, listen, children. That's who I work with. I work with children.
One of them is quite ironic, considering how we as a society treat them.
Probably sexually harassed males. Because
I
males
was
get
I was gonna
sexually
say veterans.
No,
That's terrible because we treat them bad too.
we do treat them badly. Not quite as bad as this group, though.
The
So you got
homeless?
children. Who?
The homeless?
Not the homeless.
Native Americans.
It's not a racial or ethnic group.
Uh,
Sick.
Children, pregnant women is number two. Yep.
Angela, you're protected.
But that's
Woohoo!
not who I was saying. We treat pregnant women pretty crappy, honestly.
We
Huh?
do. We do. I have a
Women?
whole
Women? God, just plain
Pregnant
old women.
women, children, and one more.
Animals?
Not animals. It's a group of humans. We don't treat them very humanely, though.
Prisoners?
Prisoners.
Wow.
The
Terrible.
hardest IRB applications to get through are always going to be minors under the age of 18, pregnant women, and prisoners. Now, I would argue that although the intention behind the prisoners as the extra protected class might have, in theory, had the right intentions, in practice, what it means is that it's very hard for people to get into prisons and study them. And so all of the ungodly, unethical, shady behavior is not always documented, right? It's very, very difficult to get IRB. And even in this program, and I know you guys are higher ed, so this is not as common, but like we have a pathway for people studying children under the age of 18 in schools. And our IRB definitely puts you through the ringer if your units of analysis are students. Okay. And a lot of this is solely because the human rights organizations that met with the IRBs to determine the like set of protective classes, right? Yeah, so it's children, pregnant women, and prisoners. Now, this certainly doesn't extend out into the rest of society because we all know Angela's not getting a seat, no one's holding the door open for her. Yeah, none of that. But if someone wants to research you, they have to go through a couple extra hoops. So the thing about the disabled, which is also relevant for children, is if you want to study, you want to do human subjects research involving children or the disabled, depending on the disability, the voice of consent is not actually your participant. So if you want to survey or observe Or interview children. You got to go to the parent or the guardian. And if you want to survey or observe or interview people that have an intellectual disability, you have to again go to the parent or the guardian. Consent is assumed to only be appropriate from somebody of like sound mind, 18 and over. Also, that's questionable about the ethics behind that, but that is also the case. Um, Disability research as a field is sadly actually still fairly brand new in social science research and in ed research. For a long time, it was just like not looked at. And now there's actually advocacy groups. There's like subsections of the American Psychology Association, the American Sociology Association, the American Ed Association that specifically focus on and support research on accommodations and disability and ability differences. Other questions? Okay, Al.
No, I just wanted to share, those that are blind get paid the most money in federal benefits.
Huh.
If you're blind, your SSI check is higher just because you're blind
Interesting.
compared to someone who's missing legs and arms, or they just get more money.
Is the assumption that it's harder to navigate the world without sight?
They put it into the Federal Register for benefits, whether they just
I would argue the reason that is because the lobbying association that represents the American Association of Blind Folks is the strongest. Because usually that's why prison guard unions are the strongest union in the country, because they hire the big time lobbyists. Yeah, so that's probably some of that. That's interesting.
yeah.
Okay, all of these quant methodological frameworks and study designs, experiments, surveys, meta-analysis, they can all be done using two kind of conceptions of time. One is cross-sectional. The study was done at one place, one point in time, or longitudinal. The difference is simply that in a longitudinal study design, you are conducting the study repeatedly over some sort of time span. This time span could be decades. This time span could be minutes, depending on what you're studying. Okay. You can do a longitudinal study using any methodology. You could do a longitudinal in-depth interview study if you returned to the same respondents over a certain kind of schedule of time and ask them the same questions. The key to the longitudinal study is that you are proposing to look at your phenomenon and how it changes over time. So you need to apply the same instrument to the sample of people to see how responses to things change over time. The sample data set in this class, the NLSY 97, is a longitudinal study that started with roughly 9,000 12 to 16-year-olds in 1997. And it followed them every single year and still continues to. So, given that and how old the cohort was in 1997, 12 to 16, so like early adolescence to like mid adolescence, right? You can look at transitions out of high school into college, transitions into the workforce, family structure changes, attitudes, opinions, perceptions, behaviors, right? When they got married, if they got married, when they bought a house, what their kind of assets are, debt, things like that. The value of the NLSY study is they are studying the same cohort predominantly, and so you can actually look at how these things are changing and happening to the same group of people. In a panel study versus a cohort, you would look to similar people over time, right? But not the exact same people. The benefit of the longitudinal framework, one, you end up with way more data. So if you're missing data from a couple subjects in a round, the next 7 years you get it, right? It's not that big a deal. You really can look at change over time, right? And you can distinguish between kind of short-term phenomena and events versus long-term, right? The short-term effects of participating in this upward bound program versus the long-term, like what it looked like a year after, 2 years after, versus what it looked like 10 years after. Um, any questions on longitudinal versus cross-sectional? Okay.
I do have a question.
Yeah.
Regarding longitudinal, um, what happens if access changes? Like, what happens to your study? Like, for instance, and I couldn't even tell you the name of like the organization, but someone was essentially doing a longitudinal style study of my job and,
Mhm.
you know, essentially questioning staffers once a year over the course of, I think it was supposed to be like the 4 or 5 years.
Okay.
But staff changes because that's
Yeah.
just how school is.
Right.
So in those cases, like what exactly happens to the study?
So that becomes a panel study then, because the position the person is filling is the same position, but the person changes. So
Hmm.
presumably the survey was about like job satisfaction or job conditions. So an informed respondent needs to be in the job, but they don't need to consistently be Verna who self-identifies as
Hmm.
this, and this, right? That's the difference, right?
Okay.
Um, as I said, you can have longitudinal studies that look at job satisfaction among university professors over a 20-year period, and you go to a new crop of professors every year, right?
Okay.
That's the condition and the characteristics they share are that. If you actually want to look at how job satisfaction amongst professors changes across their career trajectory, then
Okay.
you need to go to the same people and get to them after their first year, after their fourth year review, after their tenure, like that kind of thing. Yeah.
Okay.
Right. Um, Most large cohort studies have large enough numbers that if people, because people drop out, right, that
Yeah.
it doesn't matter. And I think I mentioned to you guys the benefit of the NLSY is that it's run by the Bureau of Labor Statistics, which has a lot of resources behind it. And they basically have like waiting list isn't the right word because people aren't necessarily waiting to get in the study, but they have lists. So when like Nora drops out, they would have, if I had dropped out when I was 17, they would have found another white 17-year-old girl from this zip code who lived in this family structure, right? Because they had that level of resources behind. Graduate doctoral research doesn't usually have that level of resources. Um, if people drop out, people drop out. I technically did a longitudinal study for part of my dissertation because I did a time diary study where I followed a group of students over 2 weeks, and they were beeped, uh, basically like solicited for information using this app on an iPod Touch, because that's how long ago I did my dissertation, every like 2 hours throughout the day, right? And so and it was the same question. So I had repeated measures over time. So even though it was only 2 weeks, I had roughly 7 to 8 data points a day times 14 times initially 200 students. I had kids drop out or just like stop responding, right? And I had enough that I could still, but I didn't have the resources to like go back in and like recruit and do that, right? So I think the benefit of the kind of federal, state level, ed org kind of longitudinal data sets is that they have the resources to kind of correct for these types of things. But sometimes a panel is appropriate, right? Because if it's not about Verna, but it's about the occupational role Verna plays, right? Then I think that's the key kind of piece in common there.
Okay.
Other questions? Okay, let's take a break. I have 6:54, so let's take until 7:10, and then we will dive into SPSS. All right. On your own, but again, entirely up to you how you want to conduct the lab. All right, so as I said, if you want to get into SPSS, let's do that. We're gonna run through some stuff again. I truly believe with all of this stuff, repetition helps. And if you end up getting through this class and honestly, all you can tell me you remember is like what descriptive analysis is, that is probably because that's all you need to know from this class, right? Because either you're just going to read some quant articles for your lit review, or maybe you're going to do a descriptive dissertation. It is perfectly acceptable. Many students have done a purely descriptive dissertation. Their questions were more exploratory in nature. They were not trying to predict something. They were just trying to understand quantitatively what something looked like. For that purpose, counts, proportions, means, kind of distribution, and the extent to which things are related to each other is perfectly fine. You don't have to do high level regression models with nesting, which I think somebody ended up reading a quant article that included that, where you compare like you guys individually, and then I nest you guys in my summer quant class 26, and I compare you to my summer quant class 25, right? You don't have to do that kind of complex analysis to do a quant dissertation. And in fact, sometimes the amount of data you end up getting dictates what you can do. So the kind of repetition around some of these basic steps, I think, is really important. So let's get back to, oh wait, actually, hold on. I am not in my view. Okay, so let's start with some frequencies, okay? So frequency statistics are simply counts and proportions. They can be calculated on any type of variable, numeric or categorical, right? If you ask people to self-identify their racial or ethnic identity, you should not be describing that variable to me with a mean. You should be describing that variable to me with the frequencies. So if you have the data set open and you want to play along at home, we're going to go analyze descriptive statistics frequencies. Okay, that is going to pop up this dialog box. And let's move the citizenship variable into the box. So we're simply going to ask SPSS to calculate the counts of each category on the citizenship variable and tell us the proportion of the sample. So you can either double click the variable or you can highlight it and click the arrow to move it into the variables box and then click OK. And you should end up with a table that looks like this. All right. So this has, for each of the categories on that variable, a count, a percent, a valid percent, and a cumulative percent. It also includes the missing information, okay? So because we are not using a data set that we compiled on our own, we're using this super large N, right? 8,984 people data set. NLSY has codes for why things are missing, and SPSS identifies those. So everything coded as a -4 is not included in the analysis. It is excluded, right? So how many of the 8,984 people did not answer the citizenship question?
1042.
Yes. Okay. So that means for For this variable, the valid sample size is what? Is it the full 8,984 or is it smaller? Smaller. Good. Al, what is the valid sample size?
7942.
Yeah. If you wanted to analyze the citizenship variable, your sample drops about 1,000 people, but it's still huge, right? So you get a count for each category: citizen born in the US, unknown not born in the US, unknown can't determine birthplace. And for each of those, you get a percent and a valid percent. What's the difference between the percent and the valid percent?
I see difference of 10%, 11.6.
What's included in the percent totals? That's not in the valid percent.
The missing.
The missing, yeah. Okay. This is a important concept. So forgive me if you're like, this is obvious. Why are you hammering this home? Just because you go out and you collect data from 100 people does not mean that you can analyze data from 100 people. Okay? Unless you set a survey up to force people to answer a question, which is a setting on surveys, right? People may skip questions and not answer them, and you will end up with missing data. Now, the best practice for this is to require an answer, but to give people the option to not answer it. If someone doesn't want to disclose their racial or ethnic identity, prefer not to answer. That is a valid missing cell then. That would be included in this kind of -4 category. That's not simply they skipped the question and went to the next one, right? So your valid sample size is your analytic sample size. All right. Now, there are 8,984 respondents in this data set. Okay. There are variables for which there are 100% response rates, 8,984. But if you want to compare variables to each other, let's say you wanted to compare age, which has 8,984, and citizenship, like maybe are older people more likely to be US citizens or something like that. Would the sample size for that comparison be the 8,984 from the age variable, or would it be the 7,942 from the citizenship variable?
8,000. No.
It would be the smaller one because it would be the one that has responses for both.
Oh, because you're looking at both.
Yeah,
Right.
you're looking at both. Yeah. So this is why sample size is so important for quant work, because yes, the survey may have gone to 200 people and 200 people may have opened it, but that doesn't mean that 200 people finished it, started it, right? I think I told you this. I had a student at the end of March turn in what she thought was chapter 4, and her sample size for analysis was in the 30s. And she had the survey had gone out to hundreds of people, and she told us her sample size was 165. She didn't require answers to questions, and people skipped questions. And so she ended up with a sample size of 30 and then was like, nothing is statistically significant. I can't answer any of the questions. So she had to go back and get more information. Questions on that? Yes, folks in the center of the Venn diagram. Absolutely. Right? Once you start slicing and dicing the data across all the variables, right? If you have a regression model where you're trying to predict whether or not someone graduates from high school, and that's your dependent variable, high school graduation, and you are using race, ethnicity, gender, age, and parents' level of education. So race, ethnicity, gender, age, and parents' level of education, 4 variables. Your sample size is the total number of rows of data that have data for all four. And not everybody who gave you, their race, ethnicity, maybe gave you their gender. So that's why if you're doing quant, it's really important to try to spread the net wide, right? This is why I encourage people. I had a student who graduated in May of 25 who wanted to study special education teachers in Orange and Ulster counties of New York State. I was like, you'll never get enough. So he put it on social media and he ended up with a sample from across the United States that was like 187 people. You gotta spread the net wide because it's not about the total number of people who open it. It's about the total number of people who finish it and in completion, right? So that's a really important thing. So the valid percent is really what you're interested in looking at.
So in creating an instrument, is it wise then to, I guess, ask questions that reap as much information from as few questions as possible?
No, I mean, I think there's still first of all, you got to be careful with how much information you try to, like, a question should garner you one piece of information, right? You can't ask too many things in a question.
Mhm.
I think that, look, there are survey methodologists who will tell you the sweet spot of survey completion is in the 7 to 12 minute range. Certainly 1 and 2 minute surveys get answered, but they can't give you that much, right? If you're trying to see like if someone's going to vote tomorrow, great. But if you want to look at something with a bit more depth and detail, it's really that 7 to 12 minute sweet spot. However, there are surveys that take far, I mean, this data set that I have, you guys, is a tiny snapshot. There are thousands of variables in this data set, and the respondents answer them every year. I think what is important, if the survey instrument or the interview protocol is lengthy, the key is clearly articulating the purpose, right? I want to sit here and I want to talk to you today about your experiences as a person of color in a predominantly white institution. I want to get a level of detail and context so I can understand like the day-to-day struggles or triumphs, right? The purpose of my study is to build a more accurate picture, right? The following survey seeks to gauge your interest in a new curriculum. The reason why I want to do that is to make sure that we roll something out you believe in, right? It's about the clarity of the introduction, and then it's also about the questions being written in a way that's not going to prime anxiety or stress, right? And but also being written in a way that makes sense, right? A number of you turned in surveys with statements and then ask people to agree or like locate themselves on the Likert scales. If statements are similar in nature, you should group them together. You shouldn't ask their people like questions about the weather and separate them with like 20 questions in between. You want people to be on topic, so to speak, right? That's why kind of survey creation is so important. But I think at either end of the methodological spectrum, because if you're asking somebody to sit with you for 60 to 90 minutes, that's a long time. The purpose of that conversation should be very clear up front, and the value of their perspective should also be very clear, right? As well as all the steps you intend to take to protect their identity, right? There's an automatic anonymity assumed with an electronic survey because you as the researcher are not interacting with the participants at all, right? Which obviously is very different in a qualitative scape. But other questions? Okay, so the valid percent is what you would then report in a table if you were describing your data. You would not say that you have citizenship data on 8,984 people. You would say you had it on that 7,942 number, because that's actually the number of people who have valid information that you can then use to analyze. Okay. So this, right, so here's the missing here, just a smaller table. Okay, so Crosstabs, again, it's taking a frequency tab and it's interacting them with each other. It's a grouped frequency table. You do it with two variables. The example here, we're going to do the variable indicating sex and then the citizenship variable, right? So this is a fairly simple crosstab because there are 2 and 3 categories respectively on these two variables. It can get more complex depending on how many responses. Same menu, analyze descriptives, but now we go to crosstabs. Okay. We're going to put the sex variable in the row. And, oh, sorry, I meant citizenship. Did I? Hold on. Yeah, sorry, this is the wrong slide, but it should be citizenship in the column. So sex in the row and citizenship in the column. If you are in SPS at home, click on cells for me and select percentages for row, column, and total. This is just doing math for you. It's basically going to tell you like the percentage of women who are citizens, the percentage of men who are citizens, the percentage of citizens who are men, rather than just give you the raw numbers. Okay, so you click OK, and out pops this table, right? Across the top row is citizenship. So the citizenship categories are down the columns, right? And then down the first column is the sex variable, 1 for male, 2 for female. And all this is telling you is the total number in each of these intersecting categories, right? The total number of males who are citizens, 3,538. The total number of females who are citizens, 3,331, right? The total number of non-citizen, non-US born. It's simply interacting two frequency tables with each other, right? So here are your row counts, right? Here, and here are simply the corresponding percentages, right? So 86.7% of the male sample are citizens, 86.3% of the female sample are citizens, right? The table includes all of this here. Okay. Questions on crosstabs, frequencies? If you're trying to figure out if you can use two variables together, a crosstab is a good first check. Because if you were to cross-tabulate citizenship and sex and all of the males were in one category, then it wouldn't make sense to see how they're associated with each other. Right? This is where sample size kind of and slicing and dicing the number starts to come into play. All right, so these are simply counts. Nothing else. All right, so now we're going to move to measures of central tendency. All right, so these are your mean, your median, your mode. You can only compute measures of central tendency for ordinal or numeric variables. And even for ordinal, it's sometimes tricky, but you need an order to things. Purely categorical nominal variables, race, ethnicity, gender, religious affiliation, calculating a mean statistic on that means nothing. The mode, which is the most reported, you can get from a frequency table. Okay. In most social science data analysis, which includes education, you just use mean. Median and mode are rarely used. Okay, so let's look at parent education. So analyze, we started with frequencies, so analyze descriptives. Now we're going to go down one more to descriptives, and up is going to pop, oh, sorry. Where's your, oh, here we go. Oh, you can do it this way too. Sorry, guys. Let's stay in frequencies. Okay, so we're back in our frequency table. Now let's reset it if you're playing along at home, because we had, what do we have in there? Citizenship. And now let's move CV, HGC, Bio Dad, which is highest grade completed dad, and then highest grade completed mom into the box. And let's click on statistics. and select the measures of central tendency, mean, median, and mode. Okay. Once you click continue and then come back here and click OK, you should end up with this box. It has the valid sample size for these and the missing, the mean, the median, and the mode. Who has, on average, higher levels of education in this data set? The respondents' dads or the respondents' moms?
Dads.
The dads.
The dads, just by a little bit, right?
Data
It's
is almost
years.
symmetrical.
Yep, almost, yep. Who has more complete data on their level of education, the dads or the moms?
Moms.
Moms, yeah. If you were wanting to include dad's ed and mom's ed in your analysis, a common technique would be to the respondents who are missing dads to replace that with their mom's level of education. Okay. Now, those are general measures of central tendency, as I said, right? So those are your mean, your median, and your mode. Descriptive analysis also includes this idea of variability. And this doesn't simply look at a midpoint or an average point. It looks at how all the data is dispersed and distributed around each other. Variability includes things like range, right? Which is your minimum value to your maximum value. It's sometimes expressed simply as that, 1 to 10. Sometimes it's expressed as the distance from the minimum to the max. Your standard deviation, which I will visually show you in a second, but your standard deviation is the distance from each data point to the mean. Okay, so if your mean is 5 and your standard deviation is 1, that means on average, most respondents will be plus or minus 1 point from the average. So most respondents will fall within 4 to 6. Yeah. Okay. Standard deviation really gives you a sense of how your data is distributed and spread, which is really important for understanding what types of analysis you can do. Okay. Variance is how far a set of numbers are spread out from the average. It's simply the standard deviation squared. You only report your variance when you have a negative standard deviation because it obviously computes it to a positive. The other two statistics that help with variability are these notions of skewness and kurtosis. This tells you if your data is normally distributed or if it is skewed or biased in any way. So a perfectly normal data distribution, which is shaped like this, like a bell curve, okay? The skewness equals 0. So anything roughly around 0, we call normal enough, okay? A normal distribution's kurtosis is usually equal roughly to 0. Your skewness tells you how much your data distribution deviates from this bell curve, right? Is it shifted to the right, positive, or shifted to the left, negative? Your kurtosis tells you how many outliers you have. If your kurtosis score is greater than 3, there's lots of outliers in the data, and you may need to think about how to treat them, right? So this, again, is a perfectly normal distribution. The line straight down the center, this dotted line, that's your mean, your average. In a perfectly normal distribution, your mean and your median, your middle value, are exactly the same. And half the distribution sits above the mean and half sits below, okay? And each of these arrows, these horizontal arrows, represent the number of standard deviations from the mean. So the shortest arrow here The one to the right is one standard deviation above the mean, and the one to the left is one standard deviation below the mean. So in a normal distribution, the majority of the data, 68.3%, falls within one standard deviation of the mean. 95.5% of the data falls within two standard deviations of the mean, and 99.7% falls within three, which means that the mean and the median are good representations of the data. If you are trying to describe the data that you have, use the average. Okay? If the data is at all skewed positive or negative, then the average is not a good representation. Can anyone think of an example of a data point in the United States where the average is not a good representation of all of the data? Al.
I would have to say metropolitan cities because it's not indicative of the rest of the country. Here is very diverse, like Los Angeles, Miami, and New York City. While if you go to the Midwest, it's not as diverse, and the population size is smaller. So you will have uh, the data be skewed mostly towards that population group. Let's say it's mostly white in the Midwest, but here
Mhm.
that
Mm.
that may
Depends on where you
not be
are,
the
but yeah, I
case.
see what you're saying. Using like metropolitan, or I would even not, I would say like major, the top three major cities in the US as exemplars of the demographics. Yep, that certainly works. Who said income? Verna, yep. Does anybody want to quickly Google what the average household income in the United States is? What came up?
Mine says roughly 121,000.
In the US?
That's what I got.
I got median of 83,730.
Yeah. Mean
That's
usually
that's
comes
the
up.
median. I thought we said average. So the average
Oh,
household
average? Yeah,
income
yeah.
is
Sorry.
roughly 121, while the median is approximately 83.
Correct.
Where put the link to that in the chat. I want to see
Sure.
that.
Ooh.
Is
Uh,
that
I
is
haven't
that
checked in a while, but it's usually like high 60s. So
uh,
let's see.
I'm using Bing.
Average
Uh,
household income. Oh, you okay? Interesting. Copilot. Okay.
I just did Google.
I mean, I could do
So
Google.
I did Google and I got 66, 622 or 67 to 69, 846. Regardless,
Uh-oh, that's
let's even go
dynamic pricing. Watch out, y'all.
let's even go with Verna though, right? What was it, Verna?
I said dynamic pricing. Watch
Yeah,
out.
yeah, yeah. But what was your, let's give the benefit of the doubt. What was your average income? One what?
121,000.
121,000. Is that a good representation of the income distribution in the United States?
Absolutely not.
Absolutely not. Why not?
Mm. Because I mean, if we set that as an average, there'd be far too many outliers in both directions.
Yeah,
Um,
right? So
mhm.
100, and but even going with Verna's 121, right?
People would not be on food stamps.
People would not be on food stamps, presumably, but even more beyond that, right? Like, let's not even think about the whether or not livable wage or not, right? What's wrong with using the 121,000 metric to understand wealth in the United States?
I think the cost of living varies between where
So
you're
there's
living. So
certainly that
121 in New York
121
City
in New
isn't
York
going to be the
City.
same in Texas.
Yep, is not the same as 121 in Philadelphia even, or 121 in Detroit. or 121 in rural Wyoming, right? There's that. So certainly context really matters because cost of living is varies greatly. Why else is that a terrible statistic? If you're, let's say you're not American, you're not from here, you're trying to understand. Al.
I was thinking that wealth and income are very extreme here in the US because you could be a Jeff Bezos, very wealthy, and your income is zero because you are
Well,
not
with all
paying,
his write-offs and such.
because
Yeah.
you're not paying any taxes.
All
Everything's
right, but
been
let's
paid
just
for.
be clear. According to your thing at the beginning, what did President Trump report in his financial disclosures?
2.2 billion
2.2
dollars,
billion.
but not necessarily in his name.
Well, regardless, yeah, sure. Okay, semantics. But let's say for a second this was precedent and all other presidents continue to make money, and we'll just ignore all the absolutely disgusting, cheating, ethical pieces of this. And let's say this is valid. A person made $2.2 billion in income last year. And you're like, oh, the average American makes 121,000. Sometimes average is an absolute garbage statistic when the distribution is skewed or has outliers.
Yeah.
Right? And that's why looking and exploring your data is really important to understand it. And so this is where, when you are initially, after you collect your data and you are looking at it, this is where you would say, okay, so I looked at my mean and my median and my mode. All right, but now let me actually look at variability. So analyze descriptives. Okay. And let's pick the two parent ed measures, BioDad, BioMom, and let's also put in the GPA variable, trans credit GPA. And if you select this options button, you can select kurtosis and skewness. So in addition to giving you the mean, the standard deviation, the variance, the range, the minimum, the maximum, it will also give you these distributional statistics. So select those, click continue, click OK. And what you will end up is this. All right, so this is a descriptives table for these three variables. It has statistics in terms of the sample sizes, right? More data for mom's ed, we already knew that. Even less data for high school GPA, right? It has the range statistic, which is the actual value from the minimum to the max. It also gives you the minimum and the max. It gives you the mean, the standard deviation, the variance, which is the standard deviation squared. And then it gives us our skewness and our kurtosis. So remember, skewness in a normal distribution, right? Going back to our bell curve, skewness equals 0, and kurtosis is roughly 0. Anything bigger than 3 has a lot of outliers. So let's first look at our skewness. What do we think here? Which of these three variables are skewed?
Isn't it
So
the dad and the
dad's
mom?
ed, it's 8. Mom's ed, roughly 8. And GPA minus 0.5. We want that skewness score in a normal distribution to be roughly 0. Which variables are skewed?
Wait, I'm sorry.
Don't say sorry. What do you
Can
need
you
help with?
can you repeat what you just said?
Yes, in a perfectly normal distribution, skewness equals 0. So anything roughly around 0 is normal enough. So which of these three variables has a skewed distribution?
Well, it's going to be
So
the dad and
look
the mom.
under
Right?
skewness, look at the statistic score.
Right. So isn't it the mom and the dad because it's higher than 0? It's
Yeah,
7.9.
right. Transcript GPA is roughly around, right? So this is how I would look at this. I would say, okay, Bio dad definitely skewed, right? Much larger than zero. Bio mom definitely skewed, much larger than zero. I might be okay with the GPA. Let me go to the kurtosis. Let me see if there are outliers. Okay, so the kurtosis score, you want to be close to zero. If it's less than three, you don't need to worry about outliers. If it's three or more, there are lots of outliers. So let's start with the GPA because maybe it was a problem, but maybe not. But now looking at the kurtosis statistic of 0.31, can we treat GPA as normally distributed?
Yes.
Yeah, right? It's small. There are no outliers to worry about. But the kurtosis statistic for the parent ed, remember, if it's greater than three, there are outliers. Are those statistics greater than three?
Yes.
Okay. We're staying in this chart. We're not going to look at anything else. We're not going to compute any additional information. Where should I turn my attention to for those mom and dad ed variables to figure out what's going on that's in this table? So I know it's skewed and I know there must be outliers because these numbers are so high. What else could I look at in this table that might give me some insight?
Your sample size?
Sample size could help. Certainly, if it was small, one outlier is going to throw everything off. These are quite large, though, so presumably it's something, it's not a one-off, right? What else could we look at?
Oh,
Look at
your range?
your range. Yes, Melissa, say more.
Uh-huh. So the dad and mom are 94, but then the GPA overall is 407.
Yeah, the GPA looks like it has a big range, but when you look at the mean, it's kind of in the middle of that range, right? 10 to 417, like roughly 280. Look at the mean for mom and dad ed and look at the range.
Pretty low compared to a big
Right.
range.
If in fact there was relatively equal amounts of data from 1 to 95, that mean should be a lot higher. Yep, exactly. Look at the range. Okay. So if you are playing along at home, what I want you to do right now is go into analyze, and I will show you this. We're going to do a little bit of a check here. All right, so
Wait, I'm
let's.
sorry. I don't want to hold up everybody, but I
No,
got different numbers. You went to analyze descriptive stats, descriptives,
yes,
and then it was the dad, mom, GPA overall options, mean, standard deviation, minimum, max, variance, range, kurtosis, skewness,
yeah.
variable list.
Yep, continue. Okay. And then what numbers did you get?
Negative 1.466 for the GPA under skewness.
Do you have your SPSS on the computer? You're on Zoom?
Yeah.
Share your screen.
It's not letting me. Hold on
Okay, no problem.
1 sec.
And don't apologize because these are the kinds of things that we all end up getting stuck in.
It's not gonna let me unless I quit and reopen, which I don't want to do.
Okay, are you in the data file from Brightspace?
Yeah, NLS Y97.
And how many rows of data do you have?
Rows, rows,
Like if
rows.
you go into the
48.
data file itself,
Oh, data view.
data view, scroll all the way down to the bottom. How many data rows do you have? Do you have 8,984?
Yeah.
And then in the variable view, You have 48 variables.
48.
And then in the missing column for all the variables, is it -5 to -1?
Yeah. Yes.
Okay, why don't we hang out for a bit after and just try to figure this out?
Okay.
It could be you have a filter on. Okay, so what I want you to do, if you have it open at home, I want you to, we're gonna do frequency tables for these two variables. Okay, so let's go analyze, descriptives, frequencies. Okay, actually reset this. Hold on, I actually solved the problem, so let me not solve the problem real quick. Okay, so analyze descriptives, frequencies, and let's put in mom and dad and mom ed. Click OK. All right, you guys should end up with these two charts, bio dad 1997, bio mom 1997. Okay, I'm gonna stop sharing and go back to my slides because I have a nicer way of looking at this for you guys in there. All right, so if you look at those frequency tables, what do we notice here? So, right, 1, 2, 3 years. Either this is counted in years. It's basically 1 through 20, and then there's 95 for both mom and dad, right? Relatively small proportion of the distribution, 6 rows of data for mom, 8 rows of data for dad, but that's clearly throwing some things off. Okay? These are the clear outliers, right? There's a 75-point jump to the highest value in the range from the next highest value. What do you think you could do with your data in terms of cleaning to prep these two variables to be used for analysis? Should we keep these people in who said they had 95 years of education? No, Verna's face just clearly said, right? No. The even if someone's parents live to be, right? And maybe you were counting that you went straight to grad school and then started being a professor. I had a 95-year-old professor in graduate school. He actually has a statistic named after him, which is in SPSS. And so every time somebody buys an SPSS license, he gets a really fat check. And he also wore a parka to class in California 12 months a year because I think he was old and cold. But for the most part, that's really unusual. So what should we do with those 6 and 8 rows of data respectively? Yeah, let's cut them. Okay, so there's a really simple thing that you can do for this. Okay, if you go into your data set and you get out of your output file and you go into your variable view. So here's remember at the bottom of SPSS, you can toggle between data view and variable view. Okay. Find those two variables, right? Rows 7 and 8. Currently missing values are labeled as the range from -5 to 1. Let's also add that 95. Okay. To both of them. And what that is going to do is it is now going to exclude those data points from the analysis, right? So now if we go to analyze descriptives, and we put mom and dad in there, and we click options, and we have our skewness and our kurtosis. Click continue, and we click OK. Right? Now our skewness goes from being, and now I can go back to the slides, which have a nicer way of presenting this for you guys. Right? So now our skewness statistic is negative 0.31 for dad and negative 0.51 for mom, right? Okay, so maybe there's something there. It's not exactly zero. But our kurtosis, which talks about outliers, are now, which were previously 159.1 and 185.3, are now 0.93 and 1.45. So are there outliers now in this distribution? Remember, if there are outliers, the kurtosis stat is greater than or equal to what? 3, okay? So removing that data adjusts the distribution of the data set and really doesn't compromise your sample size here. 7,120 on the dads and 8,290 on the moms, okay? Again, this is why sample size matters. If you had a sample size of 50 and you dropped 8 rows of data for the mom and 6 rows of data for the dad, and they may not be the same people. The people who said 95 for dad may not be the same people. You could lose as many as 14 rows of data. That's a lot of data to lose. Okay? Any questions on this? Okay, how we feeling brain-wise? Be honest. Should we dive into association a little bit, or you want to say, I need someone to say something?
Say something.
Yeah, I'm gonna need some help, but
Okay, that's okay. Rhonda, can I interpret that as Rhonda votes for a breaking point in the evening? Okay, I think that that's fair. This was a lot. Okay, so guys, to be clear now, you should be able to, with the help, right, of the notes and the recordings, walk through measures of central tendency. You can also speak to your attorney if you want, right? What we just did, right, is walk through distribution. So remember, here's your normal distribution, your mean, your median, and your mode are in the middle. Here's your skewed distribution. Here's your positive skew, right? Your mean is gets drawn when there's a high positive skew, the mean gets drawn up, right? If you did actual like assets in the United States and you included Buffett, Bezos, Gates, whoever else, the average is going to get pulled way up because they are in the billions, right? Right skewed positive. There's also left skewed or negative, right? Meaning your mean is lower than everything else because you have a lot of values towards the bottom there, okay? You use those skewness and kurtosis variable statistics, variability statistics to tell you if there's something that needs to be addressed here. And then you look at your range and try to figure out what it is. And that's when you can decide, do I keep these in? These seem valid, right? If this was income and it was a kind of a sample of people from the state of Connecticut, and you had, which has a very high mean income and a very high median income, and you had those outliers, like that's fine. That's valid to that state's data. What do you mean what the curve represents? It's basically like if you take a histogram.
No. I guess what I'm saying is, would would local AMI, especially in my neighborhood, be represented by a standard bell curve or skewed left, skewed right?
Well, I don't know what your neighborhood. So what's your neighborhood?
I live in Harlem.
Oh, you'd be skewed up. You got a small number of growing, but
So
Remember,
AMI in my
gentrify.
particular area is inclusive of,
all right, do you have NYCHA?
There's nights in, yes, there's nights in the area, but for whatever reason, when our AMI is calculated, it includes portions of Westchester and Bergen County, New Jersey.
Oh, interesting.
Yeah, very interesting.
Um, so usually AMI is supposed to stay within the county lines to be like valid. So I'm not sure why they're certainly not sure why they're pulling Westchester and Bergen County. But even if you were to just look, you would not have a normal distribution at all. You would probably have, well, I don't know specifically the neighborhood in Harlem, but I'll use mine. I live in Brooklyn. I live in Borum Hill, which is basically like buffered by Barclays on one side, Cobble Hill, Brooklyn Heights on the other side, and then it's two giant NYCHA complexes. Our income distribution has a dwindling number of outliers towards the bottom and a growing number of outliers towards the top because there are single family homes in the range of $4 to $7 million that are also 1,800 square feet. Just if you're trying to calculate. And more luxury amenity apartment buildings are coming in. The AMI though tends for my neighborhood specific that my neighborhood is in is only Kings County though. It doesn't stretch beyond that. Now maybe they're drawing some kind of like geographical net. But I mean I wouldn't trust that number.
Mm-mm.
Especially if you were going to use that to think, first of all, median income is also used to think through school funding because public schools are usually funded through property taxes.
Taxes.
And so that would be an absolutely false, right, piece of information because Westchester money doesn't fund New York City public schools. Bergen County money doesn't fund Westchester schools or New York City public schools. And the property tax funding mechanisms from New York City public schools doesn't work the same way that most Westchester districts do. So in that case, it's not at all valid. I do wonder though, if to reflect like current trends in gentrification, that is
Mm.
why those communities are being kind of looped in. But I will investigate that a little further. I think that's really interesting.
Interesting.
Okay, so what I will say is what you guys now have the skills to do though is explore data and kind of work through some of these motions to kind of clean it and prepare it for analysis, right? Figure out what's missing, figure out if there are outliers. Like I said, sometimes that outlier is real and valid, right? If you're looking at time to degree in a college setting, you might have a kid who came in with 2 years worth of AP credits, right? And who takes, a heavy load and gets out in 2 years or a year and a half versus somebody who takes 5, 6 years, right? The outliers there are valid outliers. Now, but you got to put it in the context to think through it. So as much as the numbers alone in quant research tell you the story, you still got to put it in the context of the instruments and the data that was collected, right? So you got to think to yourself. The question was, how many total years of education did your dad have? How many total years of education did your mom have? 95 doesn't make any sense, right? That's a serious lifelong learner. And without being able to substantiate that, right? You just remove them, right? Which in this case does no harm to your sample size. Okay. So, what you guys are being tasked to do for your first lab in this data set, right, is to rename and label 5 variables, right? The variables in the data set have these alphanumeric numbers, put names that make sense to you, and then run appropriate descriptive statistics for those 5 variables. So if it's a categorical variable, you're not going to do the mean. You're going to do the frequencies, okay? Then I want you to generate a new variable representing a dummy variable for a level of education you choose. This is in the recording that was posted after last class. And then I'm going to take the correlation part out since we didn't cover that today, which is fine. So that's part one. That's all like data cleaning and manipulation. You can do that collectively, in small groups, individually. And then part two, which I would like you to do on your own, is to generate 2 quantitative research questions with an accompanying hypothesis. One comparing a variable of your choosing by sex, right? So being male results in this. And one comparing by level of education using that new dummy variable you created. Okay. And then for one of those questions, draft a concept map illustrating how you think they are related to each other. So if your question is about gender and income, I want a visual showing kind of whether you think males make more, females make more. Arrows are fine, plus signs are fine. Real low stakes. What you should turn into me is a screenshot of your variable view showing me your new names and labels, the SPSS output document that has the descriptives, and then in either in a document on your own, or you can in the output document of SPSS type this in, or you can put it in the text box on the assignment page, the 2 questions and your concept map. And this is ideally due by the 9th of July, but if you need some more time, that is also fine. Just please let me know. Any questions on that?
Yes. Can you, sorry.
Don't say sorry.
Can you repeat? It was the second thing you said, generate new variable representing a new.
A dummy variable for level of education based on one of the highest degree. You can either use, so in the data set itself, it's a little kind of tips and tricks. The data set has for the respondent, not for their parents, highest grade ever completed or highest degree. Either one of those you choose. So generate a new variable that represents one of the categories. The possibly more useful one would be to use the highest degree because it has a finite set of categories.
So sort of like
College
high school,
versus everybody
college,
else.
graduate, and
Yeah.
doctoral level.
You could do college or higher versus everybody else. You could do less than high school versus everybody else. You could do graduate. I think it does. Hold on. Is it master's? Reset that. Where's the, here it is. Highest degree is, I think it's like less than high school. You gotta look through the code book to pull it up, which is also on Brightspace. I'll put the code book in the chat also. And then you don't have to analyze anything with that variable, but I want you to think through a research question and a hypothesis using that variable.
Thank you.
No problem. Other questions?
Happy 4th of July.
Happy 4th of July. I am currently on federal jury duty, which is miserable. For a
Ooh,
white collar case, which is also
love
miserable,
it.
which I cannot wait to talk about, but I can't right now.
No. Those are the
Which
best
hopefully will
cases.
end tomorrow.
Yeah,
Okay,
we'll
Melissa, you
start.
want to hang out for 5 minutes and try to, okay, I'm gonna stop the recording then. I will post the recording.